Have you ever wondered how the universe started? How all of this came into being? Ever hear the Big Bang Theory? No, not the TV show. The Big Bang is a theory astronomers use to explain how our universe came into being. The Big Bang Theory is the current model that describes the early development of the universe. Billions of years ago, there was nothing. No matter, no energy, no space. Scientists needed a way to explain how everything began, where it came from, what happened. Although there are several different theories about the origins of the universe, the Big Bang Theory is the prevalent one because no other model is as good at explaining everything in the universe. The Big Bang Theory isn't perfect, but it's the best we've got. Scientists believe our universe comes from a singularity. Scientists don't actually know where the singularity came from or exactly what it is, but they do know that a singularity is an infinitely small, hot area of infinite pressure and density. These singularities defy our known laws of physics because they didn't appear in space. Rather, space began inside them. Before the singularity, nothing existed. There was no space, no time, no matter, no energy. The universe used to be nothing and have nothing. It started as a little speck of a hot, supermassive, and superdense ball. Everything that is currently in the universe came from that speck. Every single proton, neutron, atom, and so forth came from that ball. Bang! A violent explosion hurled the material within that ball into all directions of space. One of the misconceptions about the Big Bang is that it was an explosion, like with fire and sound and, well, kind of like a bomb. It wasn't. Instead, it was probably more like a balloon being blown up, a really tiny balloon. A balloon starts small and expands outward at roughly the same speed all around. Our universe is that balloon. The universe expanded quickly after the Big Bang and continues to expand today. As the universe expanded and cooled, things started to form, including neutrons, protons, atoms, stars, and galaxies. All the different elements in the universe that exist today developed from that initial ball billion years ago. You can visualize the development of the universe by imagining a timeline. The timeline starts with the birth of the universe. Here you see the initial speck. Then the Big Bang happened. Bang! In this instant, all energy and matter is created. 1 second later, the universe expands and all the particles form, such as neutrons, protons, electrons. 3 minutes later, the universe takes shape. The protons, neutrons come together to form elements. At this time, the universe is largely made up of helium and hydrogen, which are two of the simplest elements in existence. 500,000 years after the Big Bang, the universe is a huge hot cloud of gas that is starting to cool. 1 billion years after the Big Bang, stars and galaxies are born. Gravity starts exerting its force. Although the universe as a whole expands, certain pockets of gas condense. Stars form within these pockets, and groups of stars become the earliest galaxies. 3 billion years after the Big Bang, smaller galaxies merge into larger ones. These galaxies are shaped like spirals or spheres. 6 billion years after the Big Bang, within galaxies, stars are born and die, often in enormous explosions called supernovas. The explosions of these stars distribute common elements such as oxygen, carbon, nitrogen, calcium, and iron into space. There are several main pieces of evidence that support the Big Bang Theory. One is the fact that the universe is expanding, proven with something called red shift. The second is something called cosmic microwave background radiation. The third is the abundance of different elements in the universe. The evidence that the universe is expanding comes with something called the red shift of light. Light travels to Earth from other galaxies. As the light from that galaxy gets closer to Earth, the distance between Earth and the galaxy increases, which causes the wavelength of that light to get longer. This is similar to the Doppler effect of sound waves, which also happens with light waves. I'm sure you've heard it for yourself in real life. As an ambulance approaches you, the siren pitch seems to increase, and as it moves away from you, the siren pitch decreases. This is due to how the sound waves increase or decrease depending on the movement of the object emitting the waves relative to the person hearing them. As the ambulance approaches you, the sound waves get closer together and shorter, which results in a higher pitch. As the ambulance moves away from you, the sound waves stretch out and get longer, which results in a lower pitch. If everything in the universe is moving apart from everything else, then those light waves should move further apart and get longer. Longer wavelengths of visible light are red, and that is why it is called the red shift. This red shift of light gives scientists information on the speed and direction that a star is moving. This, in turn, tells scientists that stars are not only moving away from us, but they are also moving away from each other. In the 1920s, Edwin Hubble used the 100-inch Hooker telescope in Southern California to study the Andromeda galaxy. He took pictures of faint galaxies and studied them. Eventually, he was able to calculate the velocity for the galaxy and show that everything is moving away from everything else and thus expanding. If that's true, then scientists figured that the universe was previously much smaller than it is now. All of this evidence was the first observational support for the Big Bang theory that Georges Lemaitre first proposed in 1927. If the universe is currently growing, then the universe was smaller in the past. There must have been some point in time when the universe was half its current size. Then there must have been a time when it was half that size. Think about this. If the universe has grown to currently be a size 1, sometime in the past it was a size 1/2, and before that 1/4, and before that 1/8, 1/16, 1/32, 1/64, etc. If you keep doing the fractions, you will get down to an infinitesimally small size, and eventually nothing. Yes, I know you can't really get down to nothing, but as I mentioned, the singularity from which the universe comes defies the laws of physics. The next piece of evidence that supports the Big Bang theory is the finding of cosmic microwave background radiation, CMB. With a normal telescope, all you can see in between stars is darkness. But if you have a very sensitive radio telescope, you can see more. Cosmic microwave background radiation is the faint background radiation that astronomers pick up with sensitive radio telescopes. When the universe was first born, it was foggy, not clear the way it is now. The fog was from the hot hydrogen plasma that formed after the Big Bang. As the universe expanded, it cooled, stable atoms formed, and the fog dissipated. The CMB is the remnant from that initial fog. It is the afterglow scientists expected to find if the Big Bang started the universe, and they did find this evidence to support their theory. This background radiation was discovered by accident. In 1965, two astronomers, Arno Penzias and Robert Wilson, were trying to detect microwaves from outer space for a different project. What they detected instead was background radiation that scientists now believe is left over from the beginning of the universe. The last major finding that supports the Big Bang theory is the abundance of elements in the universe. The elements in the universe were created in one of two ways. The lighter elements, such as helium and hydrogen, were produced in the first few moments of the Big Bang. The heavier elements, such as iron, silicon, and magnesium, formed in the interiors of stars much later on the universe's timeline. If the Big Bang theory is true, then scientists expected from their calculations to find certain amounts of each heavy element in the universe. Observations have shown almost exactly the amounts that are predicted, which supports the theory. The Big Bang theory has many pieces of supporting evidence, but there are three main ones. The evidence that the universe is expanding is shown with the red shift of light, the finding of cosmic background radiation that is left over from the initial heat of the Big Bang, and the amount and types of elements in the universe that are almost exactly the amounts predicted by the theory.